The moon is one of the most prominent features in the night sky, so let's learn about it. So the moon may be bright from Earth, but it is dark on the surface of the moon. This is because of the albedo, which is the sunlight reflected from the surface. If you think about what the moon is, it's a giant sphere. And the sun, off in space, is shooting off rays of light. And just like with Earth, multiple things can happen when these rays of light hit the moon's surface. They can be absorbed or they can be reflected back into space. And what we see on Earth is the reflected light of the moon. I know the moon looks super huge here, the Earth looks super small there, but the moon's the center of our thing, so we're going to keep that important. The only heat the moon gets, because there's no atmosphere, comes from the sun's light. Whatever it soaks in, whatever gets absorbed into the moon's surface, that is the heat. That's why there's such extreme temperature changes on the moon. Now, some features of the moon that we can see from Earth are the highlands and the Maria. Highlands are light colored and they are cratered and they are mountainous. Whereas the Maria is dark, smooth, and has a lower elevation. These features actually produce the man on the moon that we all know and love. Let's talk about some of the craters on the moon, because there are a lot of craters, very bumpy surface. And the craters that we see on the moon are actually impact craters, which means if we have the moon's surface right here, a foreign object from space flies in and impacts the moon. So that would be your meteorite. And a meteorite is a meteor, sorry, that's a little off screen, that contacts the Earth's surface. Leave it off, we know what that is. Okay, so objects crash into the surface. Now, when an impact happens, the force causes the things that are here to go elsewhere. This is called ejecta. All those extra particles, all those rocks and other things that get sent up, basically. If we had a meteorite come to Earth, the ejecta would be basically anything that's forced out from the impact area. This will create a crater, and the ejecta will kind of help form the mountain, but it'll also form streaks across the Earth. Long ejecta that goes really far and creates a line is called a ray. And we can see some of those on the moon. They're like the straight lines going out from craters. There are also another feature we're going to quick talk about. Those are riles. They're valleys that kind of meander. And most astronomers point to those being lava tubes from different time periods of the moon. So, some properties of the moon. Our moon is larger than other moons. So, he's much bigger, at least in proportion to other moons to planets. So our moon is bigger compared to other planets. Our moon is also made out of mostly solid rock body. So he's got big muscles here. Whereas our smaller moons have an icy core. So one additional feature is our moon is actually farther from Earth. I'll draw out Earth right here once again, a little smaller. Of course, Earth's giving it a thumbs up because Earth wants personal space. It's further from Earth than other moons are from their planets. Of course, little Saturn up there is sad too because his moon's too close. Now, the structure of the moon is the last thing we're going to talk about here, and we'll do that right over here. Our moon starts off with a liquid hot core, just like Earth. And around that is a lower mantle, which is also very hot. And then around that is a cooler upper mantle. Not cool as in that's neat, but cool as in cold. And then, of course, we have the crust, which is the surface of the moon, which has all the unique features that we know and love. So that's our moon. Hopefully, you learned something and have a new appreciation for that big bright light in the sky. Thanks for watching.